Hello, this is Professor Mary Ann Barber. In this lesson titled Modeling Variation, we study variation, which are types of modeling that occur frequently in the sciences. When scientists talk about a mathematical model for a real-world phenomenon, they often mean a function that describes the dependence of one physical quantity on another, such as in variation. Upon successful completion of this lesson, you will 1. Be able to solve direct variation problems. 2. Be able to solve indirect or inverse variation problems. And 3. Be able to combine different types of variations to solve problems. Direct variation. One type of variation is called direct variation. It occurs when one quantity is a constant multiple of the other. Think of a line with y-intercept of 0. So if the quantities x and y are related by the equation y equals kx for some constant k not equal to 0, we say that y varies directly as x, or y is directly proportional to x. The constant k is called the constant of proportionality. Suppose that w is directly proportional to t. If w is 21 when t is 6, what is the value of w when t is 19? We identify the model for direct proportion, which is w is directly proportional to kt, and we're using k for the constant of proportionality. To solve for the constant of proportionality, we will replace the w with 21, and we will replace the 6 for t, as given in the statement of the problem. To solve for k, we can divide by 6 on both sides, so we get 21 over 6. 21 over 6 is equivalent to 7 times 3 over 2 times 3. We see that the 3's cancel, and so the constant of proportionality k is equal to 7 halves. Now we can write the model. The model with the constant of proportionality would be w equals 7 halves times t. Let's continue. Now we get to actually solve for the problem, that is, find w when t is 19. In this model, we'll write w is equal to 7 halves and replace t with the 19. Multiply this. W is equal to 133, that's 7 times 19, divided by 2. Keep in mind that 133 halves and 66.5 are equivalent. During a thunderstorm, you see lightning before you hear the thunder because light travels much faster than sound. The distance between the storm and you varies directly as the time interval between the lightning and the thunder. Part A. Suppose that the thunder from a storm 5,400 feet away takes 5 seconds to reach you. Determine the constant of proportionality and write the equation of variation. Let's identify some variables. I will let d be the distance between the storm and you, and I'll let t be the time between lightning and thunder. For a direct variation, the model would be d equals kt, where k is the constant of proportionality. We are given a measurement that d is 5,400 feet and that t is 5 seconds. In order to solve for k, we will replace the d with 5,400, have k, and the time will be 5. We can solve for the constant of proportionality k by taking the 5,400 and dividing by 5. This gives us 1,080 feet per second. The constant of variation is 1,080 feet per second. And the model or the equation for this variation, we substitute in the k value to the model. So you have d is equal to 1080 times t. Part B. Sketch a graph of this equation. What does the constant of proportionality represent? From Part A, we got that this equation is given by d equals 1080t. This is a structure of a linear equation with slope 1080 and y-intercept of 0. To sketch this graph, let's go ahead and mark that the horizontal axis will represent time t in seconds, and that's for between the lightning and thunder, and the vertical axis will represent the distance d in feet, for the distance between the storm and you. This is an upward-facing graph with the y-intercept at 0. What does the constant of proportionality represent? The constant of proportionality, k equals 1080, represents the rate of change of distance per time. Part C. If the time interval between the lightning and thunder is now 8 seconds, how far away is the storm? Using our model equation, d equals 1080t, with t, the time, 8 seconds away, the distance would be 1080 times 8. The product is 8,640 feet. Inverse variation. Another function that is frequently used in mathematical modeling is inverse or indirect variation. If the quantities x and y are related by the equation y equals k over x, for some constant k not equal to 0, we say that y is inversely proportional to x, or y varies inversely as x. Suppose that w is inversely proportional to t. If w is 21 when t is 6, what is the value of w when t is 9? For inversely proportional, we use the model w equals k for the constant of proportionality times 1 over t. In the statement of the problem, we are given initially that w is 21 when t is 6. We'll use that information to solve for k, the constant of proportionality. That is, 21 is equal to k times 1 over 6. Solving for k, k will be the product of 21 times 6, or 126. The constant of proportionality for this inverse variation is 126. We can use this to write the actual model equation. The model equation then becomes w equals 126 times 1 over t, and you're welcome to write it as just 126 over t if you prefer. The question is, when t is 9, what is w? So we'll put those values into our model equation of w equals 126 over t. W is equal to 126 divided by 9, and this simplifies to 14. Combining different variations. In the sciences, relationships between 3 or more variables are common and often occur in any combination of the different types of proportionalities. If the quantities x, y, and z are related by the equation z equals k times x times y, we say that z is proportional to the product of x and y. We can also express this relationship by saying that z varies jointly as x and y, or that z is jointly proportional to x and y. If the quantities x, y, and z are related by the equation z equals k times the quotient x divided by y, we say that z is proportional to x and inversely proportional to y, or that z varies directly as x and inversely as y. Newton's law of gravity states that two objects with masses m subscript 1 and m subscript 2 attract each other with a force F that is jointly proportional to their masses and inversely proportional to the square of the object's distance r between the objects. Express Newton's law of gravity as an equation. Using the definitions of joint and inverse variation and the traditional notation for g, we express this as F, the force, is equal to g, the constant of proportionality or the gravity, times the quantity, the masses m1, m2, divided by, and for the inversely proportional, the distance is r and it is squared.